Hello everyone, in this video, this is the third video for the introduction of homogeneous. Oh, I forgot to change the number up here. So this is the third video for the introduction of homogeneous, and so I wrote here there are 7 identical balls and 3 different boxes where you are trying to divide up the identical balls to sort into the boxes. And so there will be 3 questions that I will be solving for, and this is the first one that says, when there can be empty boxes, find the number of ways you can arrange the balls into the boxes. So first, I'm going to draw 7 identical balls. 1, 2, 3, 4, 5, 6. And we have 3 different boxes. Box A, box B, and box C. So here it's basically like A plus B plus C is equal to 7, because like the A represents box A, the B represents box B, the C represents box C, box B, box C. And of course, if we add the number of balls inside of the boxes up, we will get 7 balls in total. And A, B, C. The number of balls in each boxes can be 0, 1, 2, and so on until, of course, 7. But if one of the boxes does have 7 balls, then of course the other 2 boxes will be empty, and so this will be 3 homogeneous 7. There can be 0 balls in a box, and it's obviously said there can be empty boxes. So the answer will be 3 homogeneous 7, which is equal to, we will need 2 arrows, which means 2 plus 7, which is 9, choose 7, which is equal to 9, choose 2, and 9 choose 2 is equal to 36. So now I'm going to erase this and write out the problem for question number 2. So I wrote the problem down for question number 2, which says, find the number of ways you can arrange the balls into the boxes when there can't be any empty boxes. Meaning that, first we have 7 identical balls. 1, 2, 3, 4, 5, 6, 7, and 3 different boxes. Box A, box B, and box C. And when it says there cannot be any empty boxes, it means that the number of balls in each of the boxes can be 1, 2, 3, and so on until, of course, 7. There cannot be 0 balls in a box, because that would mean that a box is empty. And so the answer to this problem is not 3 homogeneous 7. Instead, it will be a different answer, since it does not include a 0 here. And so what we're going to do is, so basically here it means A plus B plus C is equal to 7. But we're going to replace the A with lowercase a plus 1, and replace the B with lowercase b plus 1, replace the C with lowercase c plus 1. And these were all capitalized, so if we replace capitalized A with lowercase a plus 1, and b plus 1, and c plus 1, then that would mean that lowercase a, b, c will be able to be equal to starting from 0. And so now if we replace it with like this, then we will subtract 3 on both sides, which will give us a plus b plus c, lower cases a, b, c, is equal to 7 minus 3, which is 4. And so now we can use homogeneous to solve for this problem, which will be 3 homogeneous 4. 3 homogeneous 4. And that would mean that we need just 2 arrows, which is equal to 6. Choose 4, which is equal to 6. Choose 2, which is equal to 15, finally. So that will be the end of, well, never mind, I forgot that we also have the last question in the number 3. So I will erase this and then write the question down for number 3. And I also apologize for my handwriting here. It's hard for me to write from this angle. So I wrote the problem down for question number 3, which says find the number of ways you can arrange the balls into the boxes when the number of balls in each boxes has to be odd numbers. So that would mean that we have 7 identical balls. 1, 2, 3, 4, 5, 6, 7, and 3 different looking boxes. A plus B plus C has to be equal to 7. But since the number of balls in each boxes has to be odd numbers, we're going to replace A with 2x plus 1. Replace B with 2y plus 1, and replace C with 2z plus 1. So the reason why I did 2x plus 1, 2y plus 1, 2z plus 1 is because then if we do like x is equal to 1, for example, that will give us 3, and 3 is a odd number. And you may be wondering, can A be equal to like 2x minus 1, and can B be equal to 2y minus 1, and can C be equal to 2z minus 1? This will work instead that when we use homogeneous, the numbers that we are allowed to touch, I guess, have to be just non-negative numbers, which means that we have to include the number 0. But if we do this, then we cannot set x be equal to 0, because then that would mean that A is equal to -1. So like it doesn't make sense, right? The box has -1 number of balls. So that's why we need to do +1 instead of -1. Okay, so I'm also going to write x, y, z can be equal to 0, 1, 2, and so on until 7, just so that you guys don't forget. Now we're going to replace A with 2x plus 1, B with 2y plus 1, and C with 2z plus 1, and then set it equal to 7. 2x plus 1 plus 2y plus 1 plus 2z plus 1 is equal to 7. And now if we subtract 3 on both sides, that will give us 2x plus 2y plus 2z is equal to 4. And then divide 2 on both sides, and we just get x plus y plus z is equal to 2. That was just basic algebra. And so now we can use homogeneous to solve for this question. That will give us 3 x, y, z homogeneous 2, which is equal to, we will just need 2 arrows, 3 minus 1 plus 2, which is 4. Choose 2, which is equal to 6. So that will be the answer for question number 3. And that will be the end of this video. Thank you for watching, everyone, and have a great day. If you didn't watch the first 2 videos for the introduction of homogeneous, please go watch that. So thank you for watching, everyone. Have a great day. Bye.